Hey, happy Wednesday, guys. Wow, I look tired. Anyone else tired? Anyone else going a little crazy with this coronavirus thing? God, it is. Just be honest with you guys, it is. It's about 10 o'clock on Tuesday night, and I should have had this done a week ago, but I didn't. I'm like, y'all, life is moving and it's busy, and I got family stuff, and I got work stuff, and I got life stuff and it's kicking my butt. So if you're sitting there struggling or going, holy cow, this is hard to do, but you're still doing it, nice. You're doing it. Okay. That's a win. Good job. I'm proud of you. So you're not alone if you're tired. We're all there. We'll get there. I said this yesterday, but we literally have 1 month left and we're done. Okay. 1 month, June 5th, we're done. So hang in there, keep plugging. We started a new unit yesterday. Okay, and we started talking about acids and bases. And I know some of you see that and go, oh, gee whiz, it's chemistry, it's science. And it is, okay, it is. But the reality is, these are just things we have everywhere, all over, in our houses, in your food. Your body is full of different acids and bases. So this, I think, will actually help you with your understanding of the world around you. So it's a little less nerdy, and maybe a little more practical. Okay, and that's okay. So also, acids and bases are something you've been taught since elementary school. Since you were a little kid, they taught you about acids, they taught you about bases. So we're not going to teach you anything different, I don't think, I hope, but we're going to build on what you know and build and build and bring it up to kind of the 10th grade level and the chemistry level of what is an acid, what is a base. That's all we're going to do. So in Google Classroom, here's the video, right? There's a note sheet. Make sure you fill that out. When you fill it in, click turn it in, done, credit, done. Okay, super easy, super K. So here we go. We are going to talk about acids and bases. See if I can get this set up. Boom, boom. Here we go. Oh, all right. So let's start with acids first. Okay, so what is an acid? If you were to try and nail that down, there's a lot of properties that acids have. There's a lot of things that would describe an acid. It actually is a Latin word. It comes from a Latin word called acidus, which means sharp or sour. So if you ingest something that is acidic, you're going to go, it's a little sour, it's a little sharp. Those are like those Sour Patch candies, or those sour, what do they call atomic warheads. I know when I was a kid, they had these like jawbreakers that were atomic warheads. They called you pop them in, you pucker up. They were just brutal. Okay, that's a characteristic of acid. That's where we get the word acid, is from that Latin word acidic or acidus. But the best definition I've ever heard for an acid, okay, is an excess of buildup of what are called hydrogen ions. Now, notice it does not just say hydrogen, done. Okay, that second word is really important. What we're looking at is the hydrogen ion, or that H plus. If something gets a buildup, an excess, I just start building up, and there's one, and there's one, and there's one, and there's one. The more of these hydrogen ions that start to show up, the more acidic something becomes. Okay? So when you see something acidic, in your mind, I want you to say, wow, that must have a buildup of hydrogen ions, or H pluses. Okay? So what are some properties? If you were to be given a substance and say, is it acidic, yes or no? There's some properties you could say, ooh, acids tend to have these things. Number one, they taste sour. Okay, that's one thing. Number two, they conduct electricity. It's one of the reasons why batteries actually have acid. If you ever worked with cars, a car battery is full of fluid, of liquid, and it's battery acid. It's an acid, it's acidic. It has a whole bunch of these ions, a whole bunch of pluses, a big positive charge. You've also seen on a battery, there's positive side and a negative side, right? What's that positive? It's actually a buildup of H pluses. It's acidic. Another property is they're corrosive. You know, if we were back at school and we're in the lab and I were to take like hydrochloric acid and I pour that onto my hand and it just, it would be so strong depending on the concentration. Remember molarity, right? Last unit. If I had like a 10 molar HCl, it would burn a hole right through my skin. Okay, it's corrosive. It goes through fabric, it goes through skin, it can corrode things through things. Okay. Some acids, let me move my big face out of the way. Some acids react strong with metals. Okay. And if metals touch an acid, there's a reaction there. Another thing, and we'll try and do some of this if I get back to school and get some of these strips of paper, they're called litmus paper, and they're just little blue strips of paper. And if you dip them into an acid, the blue paper actually turns to red. And so that's an indicator that, we have a whole bunch of these H pluses. Okay, we have a buildup, an excess of H pluses. And that means it's an acid. Okay. Well, where in the world do we use acids? Well, we use them in a lot of places. One of them is vinegar. If you ever had vinegar, that's actually, it's called acetic acid is actually the scientific name for it. It's just vinegar. Citric acid, it's all over in your foods. It's a preservative. It's in lemons, it's in limes, it's in oranges, a lot of those fruits, okay? Ascorbic acid is the actual chemical for vitamin C. If you ever heard of a vitamin C, which by the way, they're finding is maybe something that can help fight corona. So vitamin C, this ascorbic acid might be a very important chemical. Sulfuric acid, they use that in making fertilizers, in making steels and paints and plastics. And we already talked about you find it in car batteries. So acids are a really big part of our world around us, in our food, for the vitamins our body needs, for the products that are made, and even for energy, for battery sake. Okay. Now, the opposite of an acid is a base. And acids is maybe more commonly talked about, used in our world, but the opposite, because everything has an opposite, right? Good and bad, high and low, happy and sad, right? Those are opposites. Well, acid, the opposite of that is base, okay? So what's a base? Again, the best definition I heard, it's another buildup, it's an excess, but now instead of that H plus, it's this OH minus. Well, that would make sense, right? If acids are pluses, well, what's the opposite of plus? Minus. So bases are a buildup of a negative charge. And more specifically, what's called hydroxide. OH is hydroxide. Hydroxide ions, OH minus. So again, if I have a whole bunch of OH minuses, I start to build up a negative charge. I start to build up an excess of OH, and what I form is this thing called a base. Now, another word for a base is alkali or alkaline, okay? But bases, acids opposite, bases, and alkali, both of them are a buildup, excess of these OH negative hydroxide ions, okay? Now, because they're an OH minus, and hopefully you know this, opposites attract. So bases love to attract, bring on acids. Well, why? Well, because negatives love to attract positives. So OH minus and H plus base acid will attract each other. And we'll talk about that later as we move along, okay? So what are the properties? How would I know if I had a base? We said, you know, with acids, they taste sour. Well, bases taste bitter. For example, chocolate. chocolate is super bitter. Now we add sugar because it's sweet, but I don't know if you've ever had like straight chocolate. I remember when I was a little kid, my mom had a can of Hershey's sitting in the top cupboard, and I saw that, and I wasn't allowed to eat a lot of sugar as a kid, so I saw that. And one day my parents walked out. They went somewhere, I don't remember, but I remember thinking, I want some chocolate, and I remember seeing that Hershey's up there. I knew what that was, so I snuck into the counter. I popped it, and it was chocolate powder, right? It's like a hot chocolate mix, right? So I'm thinking, ooh, and I knew I didn't have enough time to get it and pull out the milk and mix it up. So I'm like, I scooped it and I looked around and I just took a bite. This was straight chocolate, unsweetened, no sugar. It was the grossest, most bitter taste. I was like, that's what I did. Well, I have powder in my mouth, right? So I'm going, and there's spit, and it made this like powdery spitter, just black everywhere. And it's like dust and slime and I got it running down my face. Well, sure enough, then my mom walks in. She looks at me, and I'm sure I had chocolate all over, and there's powder all over the kitchen. And she looks at me and she's like, well, have fun cleaning that up, and just left. I was like, oh, had to clean it all up. Nasty. But who knew chocolate is gross? It's disgusting until you put in some sugar, right? Then, yeah. But why is it bitter? Because it's actually a base. Okay. Another real common characteristic is it feels slippery, like soap, right? You put soap on your hands, it feels slimy, slippery. Soap is a base. It's corrosive. Well, now acids can be corrosive too, so that can be a little confusing. But it also can conduct electricity. Well, can acids? Well, yeah, right? Same way. Why? Because it has a charge, that OH minus. An alkaline battery, that's like Duracell, right? That little bunny, right? Energizer, those little alkaline batteries, they conduct electricity. Now, bases are different in that they do not react with metals. Acids, remember, do. Bases do not. That's one of the reasons why one real common base is Drano. Okay, so if you get a clogged drain, you can take a really strong base, which is nasty, by the way, dump it down your drain. You don't have to worry about it. You don't do that with an acid, because if you do that, your metal pipes might react with the acid. However, bases don't react with metal. So if you drop a base down your pipes, no big deal. And then similarly, you can change litmus paper. Now, the opposite of a base is true because acids and bases are opposites, right? So instead of turning blue paper red, a base turns red paper blue. But you can see that as an indicator, and we'll talk more about that next week. Okay, so what are some uses? Well, soaps, ammonia, that's like window cleaner, Windex. Dirt and grease react with that OH. So if you just take your hands under water and just do this, they don't really get that dirty. And you put soap, now that soap actually reacts with grease and oil and dirt, and there's a reaction there. Chalk, right? When I was a kid, we had chalkboards. You write everything on chalk. Chalk is actually basic. It's a base. Oven cleaner. Your blood, if I could actually prick my finger and pull out some blood, and you look at that little red stuff, it is actually basic. Okay, it has a buildup of OH ions. And so again, just like acids, bases are in our world, they're in our house, they're in our foods, they're in our diet. Okay, they're a really big part of who we are. But acids and bases, again, are opposites. So acids, remember, in summary, oops, acids, let me go back one more. Acids are a buildup of H plus ions. Bases are a buildup of OH minus ions. Acids are positives, bases are negatives, but it's a buildup of these ions. Okay, so that's just a real short summary of what is an acid, what is the base, what are the properties, and how can you identify some of the common ones. Hey, tomorrow we have Chemistry Live. What I'm going to do in my kitchen, I'm going to pull out 10 common items I have in my kitchen, and we're going to test them. Is it an acid or is it a base? Okay, so there's a test. It'll take about 20 minutes. Tomorrow, 1 o'clock, 1 o'clock, 1 o'clock. Okay, tomorrow, Chemistry Live. Get there, get done. We don't have many of these left. We got 1 month left of school and we done. Okay, hopefully you wrote down these notes. Again, you can do it on paper, you can do it on that Google. Turn it in, get credit for it. That's all I got. Boom. We'll see you guys. Take it easy. Uh-oh, I'm out.